Let's investigate the decay of the TauLepton, which is represented here as the ordered pair S equals -2 divided by 2, which is -1, comma, -3. And the corresponding V and T assemblies. Here we have 1, 2, 3 V assemblies, and then we have a V prime anti-V prime assembly and a T assembly. Now, if we look at these V assemblies, we'll see that the T components here are plus and minus, so cancel each other out. And so we only need to consider the V's. And so we have -1, 2, 3 V's. And then over here we have a plus V and another plus and minus pair, so we have -3 plus 1, which leaves us 2. So here is corresponding -2 on the S component of the ordered pair. And now for the T component, which is -3, as we saw, these pairs cancel each other out, and so we only have -T, 2 -T's for the anti-prime V, and a -T for the T, anti-T. And so we have 1, 2, 3 for -3, which corresponds to the T component. Now, if we look below here, we have the opposite sign ordered pair of S and T, and the opposite sign assemblies of V and T rishons for the antiparticle. Now, we can look at the graphic representation of these T and V assemblies, and we see here we have the 3 V's, and we have anti-V prime and the anti-T. And so here we have 3 V's making a generic neutrino paired with a boson minus. And this is the composition of the TauLepton. And here below we have the antiparticles. Now, we can see that if this scalar boson minus interacts with a anti-T prime and T prime rishon, they will form a scalar boson minus now composed of a T prime and an anti-T rishon, which now combines with the generic neutrino to form the decay product of the TauLepton, which is the tau neutrino. Now, what is emitted to form the tau neutrino is a scalar boson minus, but now composed of the anti-V prime and anti-T prime, not just an anti-T. And also associated with this decay process will be a vector boson 0, carrying a spin of -1, along with the boson minus, giving us our vector W particle. Now, this vector W particle, if it does not decay but interacts with the anti-tau lepton, then the anti-V and V prime will annihilate, and the anti-T then will form again a boson 0, which will combine with the generic anti-neutrino to give us an anti-tau neutrino. Now, let's take a look again at this decay process in terms of the ordered pairs of the combinatoric schema. And so here we have the tau neutrino, composed, as we said, of the generic V and the boson 0, scalar boson 0. And we can see that now we have the 3 minus V's plus 2 more minus V's, and then a plus and minus giving us a minus 5, which we see here in the top of the yellow box, minus 5 divided by 2. And then here we have 0 pairs, and then we have a plus and minus pair, which gives us a 0 for the T component of the ordered pair. Now, here we have the boson minus that was emitted, that is now composed of a anti-V prime and an anti-T prime, which we can see have 3 plus V's on top and 3 minus T's on the bottom. So we have a 3 halves for the S component of the ordered pair and a minus 3 for the T component. And here we have the vector boson 0 that's carrying the minus spin 1 associated with the decay. We still have here the tau lepton, which we, as said previously, when the boson plus here interacts with the minus boson here, then this will be converted from a tau lepton to a tau neutrino lepton. And so the final products will be a tau neutrino composed of a generic neutrino and a boson 0 composed of a T prime and a anti-T rishon. And likewise, an anti-tau neutrino composed of a generic anti-V and then an anti-V, anti-T prime rishon and a T prime rishon, as we have already shown here graphically, as a result of the interaction of the emitted vector W boson minus with the anti-tau neutrino.